of a variable. In order to understand what is the domain of a variable, we have to go over evaluation of algebraic expressions, also known as formulas, first. Suppose they ask you to evaluate the following formula: y equal 12 over x for x equal 4. If we follow direct substitution for x equal 4, y should be equal to 12 over 4, y equal 3. Input 4 will give us an output 3. We can say then that we have successfully evaluated x equal 4 into this formula, in the sense that we got a meaningful output, a real number 3, right? Good. Now, suppose they say now evaluate y equal 12 over x, same formula, but now for x equal 0. Well, direct substitution again will show that y should be equal to 12 over 0, y equal undefined. This time we cannot say that we have successfully evaluated x equals 0 into this formula, right? Because we didn't get, as before, a real number as our output. We got instead this undefined result. So the idea behind finding the domain of a variable is to collect all the good inputs, the inputs that are going to give us good outputs. So, for instance, notice that in here the only value of x that is going to give us this undefined situation is x equals 0. So then we can say that the domain of x in this formula should be a set of all real numbers except 0, right? All real numbers can be evaluated into this formula. They will give us good outputs except for 0. So you take away 0 from the set of real numbers. Now let's generalize this idea. Let's think of this in general. So let's go to the next page. In general, domain of a variable x in a formula is the set of all values of x for which the formula can be evaluated. To put it simple, the set of all good inputs for the formula. So now let me give you an example of how you compute the domain of a variable that is part of a formula. Let's consider this example 1. Find the domain of x for the expression 3 divided by x minus 5. In order to find the domain, we have to think of all good inputs, right? So what should be the domain here? Notice that the only value of x that will make this division undefined will be x equal 5, because 5 minus 5 is 0, 3 over 0 undefined, right? So the domain of this expression should be all real numbers except 5. Notice something. This number 5 is the opposite of this number, so opposite. This is useful to notice. Okay, Let me give you more examples. Let's go to the next page. Here, two more examples. Example 2. Find the domain of x for the expression 8 over x plus 3. Remember, find the domain is about finding all the values of x that will not give us trouble when we compute this formula, right? So, domain will be all real numbers except for the numbers that will give us 0 here on the denominator, right? What number will give us 0 on the denominator? Well, it must be the value of x, which is opposite to 3. The opposite of 3 minus 3. So domain should be all real numbers except minus 3. Notice again, the number I write here is just the opposite of this number that appears here on the denominator. And also notice that it's only denominator equals 0, which gives us an undefined situation, right? So always look at the denominator. The numerator does not play this game, so only denominator opposite here. Alright, let's take a look at this example number 3. Find the domain of x for the expression x minus 2 divided by x minus 7. Again, to find the domain, you have to figure out what are the values of x that will make the denominator 0, right? And you have to take that away from the set of all real numbers. So the domain here will be all real numbers except the value of x that will make this 0. That is clearly 7, right? Opposite of this, right? So except 7. Again, notice this guy opposite. Okay? You may say, what about 2? 2 is on the numerator. I just said that the numerator doesn't play this game, right? The undefined situation comes from denominator being 0. Numerator could be 0. It's okay. Indeed, in fact, if you evaluate this expression for x equal to 2 minus 2 is 0, 0 over 2 minus 7, which is minus 9, will be 0. 0 is a meaningful output, so it's the number 2 is okay. So all real numbers except 7. Domain. Okay, let's go to the next page to see one more example. This time, this is a different form, worth going over. Suppose they say, which of the following numbers is not in the domain of x of the expression x plus 7 over x minus 9. Notice that this is saying which of the following numbers is not, this is very important, this part, look, is not in the domain of x of the expression x plus 7 divided by x minus 9. So again, we start by saying domain will be all real numbers. It always starts with all real numbers, so all real numbers except we look at the denominator, take the opposite, so except 9, right? So all real numbers except for the number 9 are the domain of this variable x. So the number 0, 1, any number, the only bad number is 9. So since they want you to identify which is not in the domain, well, negative 7 is in the domain, it's a good input, 7 is a good input, 0 is a good input, even negative 9 is a good input. The only bad input is 9. So this is the one that you have to pick as your answer, right? 9, because 9 is the only one who is going to give us 0 here, the denominator, and it will cause this undefined situation. So another way to think about a domain is this: if you imagine that the algebraic expression is a machine, you're supposed to take away anything that could break the machine, right? In this case, out of all these numbers, the only one that would break the machine is the number 9. The other numbers are okay. So 9 is not in the domain of X. So therefore, that is the answer.